All right, new chapter, right? Chapter 3. We're talking about pure substances, properties of pure substances. What is a pure substance? A pure substance is a substance whose chemical composition is the same throughout. For instance, nitrogen, um, helium, even molecules like H2O. H2O is the same throughout. It is homogeneous. CO2. So some of these are going to be pure substances that we are going to be looking at and talking about. Air could be a pure substance if it's homogeneous. So something that is homogeneous if it has a fixed chemical composition throughout. So it could be molecule, it could be a mixture like air. But you know, a lot of the times we're looking at H2O, we're looking at air, even like a refrigerant. Refrigerant 134A we'll look at a lot. Those are pure substances. Now, a pure substance, let's see here, could actually be a mixture of phases. A pure substance, can I write this? A pure substance could be a mixture of phases. For example, a liquid water water vapor mixture. Could be a pure substance. Okay, if water is boiling, or if water is changing from liquid to vapor, we've got a mixture of water that is liquid and vapor. As long as the liquid and vapor have the same chemical composition, as it's boiling, it still is a pure substance. Okay, so a pure substance could be a mixture of phases, as long as everything in the mixture, vaporizes at the same temperature. For example, air, if air for somehow was changing from the phases, all the different chemicals that are in the air might vaporize at different temperatures, and so if one vaporizes before the other, then it's no longer a constant fixed composition throughout. So, but one thing that is water. Water and refrigerant, those we can have a mixture of water and vapor, and it is still a pure substance. Okay, obviously the phases of a pure substance would be solid, liquid, and gas. You know that, but we want to make a note that for solids and liquids, there's not much change in volume with heat compared to a gas. Very high change in volume. Very large change in volume with heat. Okay, we'll talk about this later, but for gases are kind of very different than liquids and solids, obviously. We can treat them differently, and sometimes we can use the ideal gas equations but never use those ideal gas equations for liquids or solids, right? I mean, that seems obvious, but sometimes we're just not thinking. If it is a liquid, don't use ideal gas equations, or never use ideal gas equations on liquid vapor mixtures. Never use ideal gas equations on liquid vapor mixtures. Anytime there's any liquid in there, it's no longer an ideal gas at all. So don't try to use any equations that in the future that we will derive as ideal gas equations. That's obvious, but I didn't emphasize it the first few times I taught it. See, way too many ideal gas equations on a liquid vapor problem. So, all right, so we're going to be looking at things that maybe are changing phases, solids, liquids, and gases.